Hello everyone and welcome to my session. First of all, thank you so much, organizer, to give me this opportunity to present my experience and knowledge about applied AI for mining. I'm Ali Soofastaei, an AI program leader in Valley and CEO of Soofastaei Institute. And today we want to talk about applied AI in mining 4.0, and we want to discuss about the different dimensions of this application in the old industry mining. In the last 15 years, I have studied and worked in the field of advanced analytics in mining. I graduated from the University of Queensland in Australia and I completed my PhD thesis, and after that postdoctoral research flow in the field of AI application in mining aimed to improve energy efficiency, safety, sustainability, and reduce gas emissions in surface mines. After that, I joined BHP and later Valley to make this dream true, to have applicable tools for mining industry to use this new technology and knowledge to improve their performance in different area. I also had the chance to work with a great team to publish many different reference books in this area, and also I was very active to attend different conferences around the world. And today I try just to present a couple of slides, show something about this experience and knowledge. But if you are interested in having more information and downloading some material, you can see my website, that is www.soofastaei.net, and you will have access to different studies and research results. Mining 4.0 applies the concept of Industry 4.0 to mining, which means activities related to intelligence mining. In other words, it's a general term for the digitalization and automation of mining operations, both above ground and underground. The mining sector lags behind other sectors in implementing digitalization and automation, but is moving in the right direction. Mining 4.0 means automation in all mining processes, including extraction, transportation, and processing. It's inspired by various factors such as cost reduction, health and safety, higher availability in day-to-day operations of mining equipment, longer equipment lifetime, reduce uncertainty of mining operations, increase productivity, reduce negative impact on the environment, and real-time data availability and monitoring. It's based on the understanding that the mining industry can only maintain its competitive advantage if it can combine reliable technologies with innovative business models to create new products. In addition, Mining 4.0 allows sustainable production. For example, technologies associated with Industry 4.0 make it possible to save on transportation costs, treatments, and disposal of non-useful minerals. Another aspect of Mining 4.0 is the low-impact mine in closely populated areas. This is a mine with a minimal negative impact on the environment and the urban regions. Even so, high productivity, high security, and efficient resource consumption are expected. So while the top mining companies worldwide total operating expenses reaching around 15 billion US dollar, efficient operational methods using AI, now called smart mining or intelligent mining or Mining 4.0, is rapidly advancing. McKinsey estimates that by 2035, the age of intelligent mining achieved through autonomous mining using data analysis and digital technologies like AI will save between 290 billion and 390 billion annually for mineral raw material procedures. The mining industry faces several challenges, both currently and in the future. These challenges include increasing pressure to reduce the industry's impact on the environment, rising energy costs, and a need to transition towards low carbonization. digital transformation and data management, and addressing the rising demand for minerals and resources in a sustainable manner. These challenges require innovative solutions and willingness to embrace change to ensure the long-term viability and success of the mining industry. First, environmental concerns. Mining activities have a significant impact on the environment, including air and water pollution, soil erosion, and deforestation. And these impacts can lead to severe health consequences for both humans and wildlife. The second one is resource reduction. As we continue to extract minerals and other resources from the earth, we are depleting them at an unsustainable rate. This can lead to storages of critical resources in the future. Number 3 is safety issues. Mining is dangerous, with the risk of accidents. Ensuring the safety of workers and communities near mining operation is a significant challenge. Number 4 is political and social issues. Mining activities often occur in areas with original or demoted populations, leading to social and political conflicts. Mining companies must navigate these issues sensitively and transparently. Number 5 is cost and efficiency. Mining is a capital-intensive industry, and the cost of extracting minerals can be high. Companies must continually seek ways to improve efficiency and reduce costs to remain competitive. And the number 6 is technological advancements. The mining industry is undergoing a technological revolution with innovations such as automation, AI, and data analytics transformation the sector. Companies must stay up to date with these changes to remain competitive. Digital solutions play a critical role in promoting responsible mining practices. By leveraging technologies such as artificial intelligence, big data analytics, and the Internet of Things, mining companies can improve their environmental, social, and governance or ESG performance in several ways. One key area where digital solutions can enhance responsible mining is environmental management. Using real-time monitoring and predictive analytics, mining companies can identify and address potential environmental risks before they become a problem. For example, digital solutions can help companies monitor water quality, air quality, and noise level to ensure agreement with environmental regulations. Digital solutions can also promote responsible mining practices by improving social performance. For example, digital solutions can help companies monitor labor conditions and supply chain practices to ensure they meet ethical standards. Additionally, digital solutions can help mining companies engage with local communities to promote transparency and build trust. Finally, digital solutions can enhance governance by improving data management and transparency. By using digital technologies for track and report on key performance indicators, mining companies can improve their accountability to stakeholders and promote good governance practices. In overall, digital solutions can help mining companies achieve their ESG goals by promoting responsible mining practices that are environmentally sustainable, socially responsible, and transparent. In our view, 000 mining is coming. Zero harm, zero emissions, zero entry. Zero entry refers to the elimination of human entry into the mining operation. This is achieved using remote-controlled or autonomous machine operating in hazardous environments without risking human lives. This improves safety, reduces costs associated with safety measures, and increases efficiency by allowing devices to work around their clock. Zero harm means eliminating all accidents, injuries, and fatalities associated with mining operations. This is achieved through digital technologies such as real-time monitoring and predictive analytics, which allow operators to identify and address potential safety hazards before they become a problem. This helps to create a safer working environment for miners and reduce the financial cost associated with accidents. Zero carbon emissions refer to reducing the environmental impact of mining operations by reducing carbon emissions to zero. This can be achieved through the use of renewable energy resources such as solar, wind, and hydropower, as well as the adoption of energy efficient technologies such as electric vehicles and automated systems. By reducing carbon emissions, mining operations can help mitigate climate change's impact and contribute to a more sustainable future. Overall, digital mining has the potential to transform the mining industry by improving safety, efficiency, and sustainability. By aiming for zero injury, zero harm, zero carbon emissions, mining companies can create a safer, more sustainable future for their workers and the planet. But intelligent mining is still far from this, and its vital importance becomes, more evident daily. However, mining companies are already hyper focused on safety, building solar farms to run operations, and automated trucks, drill rigs, water trucks, etc. are working, in reality. The transition to 000 mining is perhaps only 1% complete. For example, there are some 300, 400 automated haul trucks versus 45,000 across the entire global mining fleets. Therefore, it's less than 1%. However, automated equipment is shown to be safer, more productive, and lower cost. So it's just a matter of capital, effort, and time. The shift to zero emissions or low carbon economy it's gathering pace. In the mining industry, digital transformation goes beyond just implementing technology in mines. It requires a fundamental shift in decision making, skills, worker involvement, and resource management. It involves creating a culture that embraces innovation, experimentation, and agility. A digital culture encourages collaboration and communication across different departments, promoting a more integrated approach to business operations. Digital solutions can help to reduce waste, optimize performance, and improve resource management, including energy consumption. Accurate and timely data are essential in making better decisions in intelligent mining. By effectively managing different resources such as labor, equipment, energy, and infrastructure, intelligent mines can make significant, strides toward sustainability. Digital technology adoption can also positively impact local communities, improving infrastructure and education. However, achieving successful digital transformation in mining requires organizational change, including a shift from traditional thinking to more flexible and agile models. This transformation must involve integrating core and support processes, augmenting transformation and communicate. It's important to all levels of this organization. They must also be open to change, willing to take risk and experiment with new technologies and processes. Mining companies must bring in new talent and re-educate their current workers to ensure successful digital transformation. Influential digital transformation culture requires employee engagement and participation. Employee must be empowered to suggest and implement digital solutions to improve their work and the organization's performance. This involves creating a learning and development environment that supports the acquisition of digital skills and knowledge. The digital mine has five essential parts to make it work well. First, automation and remote operation. Big mining companies use machines that can work independently and be controlled from after. This makes it safer, faster, and cheaper. Small mining companies can also use this if they start a new mine. Second one is real-time data capture. Sensors that can sense things and send information immediately are helpful for planning and decision making. This is relatively inexpensive and is often included when buying mining equipment. Number 3 is digital twin, digitalized geological engineering and asset data. Number 4 is drones, small flying machines that can take pictures and collect information, can help with stock control, safety, and inspection. And number 5 is wearable devices that people can wear, like watches or glasses, can give instructions for fixing machines and improve safety. In the future mining value chain, highly automated core operational processes will deploy various digital capabilities. Autonomous vehicles will improve safety and productivity and reduce costs through the fuel and maintenance saving and data collection, inspection, stock control conditions, and safety monitoring will be done using drones and etc. A connected network of low-cost, highly capable sensors will use Internet of Things or IoT technology to capture real-time data, enabling integrated planning, control, and decision support. A digital twin will be constructed using geological engineering and asset information such as ore body models, engineering drawings, parts catalogs, and service manuals. Continuous improvement of the digital twin will be possible through data from sensors and location-aware mobile devices, accurately reflecting the physical environment. Standardizing data formats will allow ongoing system interaction across the mining value chain. Combining remote operations with the above mentioned capabilities will result in fewer people in hand-on operational roles, improving productivity and safety and reducing overall costs. A center part at the mining 4.0 concept is related to intelligent integration. Automation has brought us 3D, 4D, and 5D processes, bringing current planning and future scheduling into the industry with the possibility of working in parallel across continents. The next wave of digital innovation will not replace these technologies or specialists, but integrate them. For decades, we have been automating workforces in nuclear, automobile manufacturing, oil and gas, and of course mining. Global equipment and control system manufacturers supply modular components that are easier to add to overall control systems. These slides show the new digital solutions applicable in every step of the mining value chain. As automation spread across organizations, need has become, apparent. The role of integration in these systems, whether vertically or horizontally across the organization's value chain. Vertical integration refers to the ownership and control of multiple stages in the mining value chain, from exploration and production to processing and distribution. In other words, a mining company that is vertically integrated controls the entire production processes, from extracting the raw materials from the earth to selling the final product to the customer. As a result, vertical integration can lead to cost saving, as companies can reduce transactions cost and optimize production processes by having greater control over the supply chain. Horizontal integration, on the other hand, refers to expanding the mining company's operations with the same stage of the value chain. For example, a mining company specializing in a gold mining might require another gold mining company to expand its operations and gain economies of scale. Horizontal integration can help mining companies to increase their market share and competitiveness, reduce costs, and increase efficiency by consolidating operations. Innovative companies differentiate themselves from others in the mining industry by bringing automation systems and advanced asset management into projects at the early stage. Digital mining and mineral solutions previously supported mining operations and mineral processing. Innovation from automation and control, along with our broader capability across maintenance, procedures, and environmental services, now allows us to offer deeper support on the drive to the future mine. As our expertise grows, further integration means more significant saving and increased earning for mining companies. One of the key points in the mining 4.0 is nerve centers, or the new model of research and development, including the innovation in a digital era. In a digital mine, the nerve center is critical in all steps. It refers to a centralized system that brings together data from various stages of the mining value chain. This system enables better planning, control, and decision making, optimizing volume, cost, and the capital expenditure. Additionally, it promotes a safer working environment. Here in this slide, you can see one example of the successful nerve centers or research and development models for a digitalized mine. As you can see here, we are collecting the business problems from different areas, for example, for operations, for maintenance, for shipping, for marketing, and all of these problems coming through the business hub. And in the business hub, we will evaluate the problem situation based on the different criteria and procedures that we have. And if we reach to this destination that we can solve this problem by a digital solution, then we will make a plan, and then we will work with our partners. Our partners here would be research centers, startups, OEMs, and universities, because we are working on the edge of the knowledge, and we need this collaboration. When we reach to the initial solution, we need to test the solution as a pilot, and if we could reach to the feasible results, and when we complete the proof of concept, then we will start the actual project, and we can work with the big companies, same as Deloitte, Accenture, IBM, and others, to develop the final product, and then we will deliver the product to the business, and they are using the product. But we need the nerve center or AI center in our mining companies to look after the product for any potential maintenance, enhancement, or improvement. In mining 4.0, miners oversee production and make decisions based on the data about processes and machines. They move around the mine instead of just watching from control room. They can interact with others in real time, even when not physically present, and control products using digital twins. Wearable sensors embedded in clothing help miners perform their job safely and efficiently. They monitor the location and the high related metrics, enhancing the miner's sense and memory. This helps minimize the human error, because by working conditions or fatigue, and reduce the risk of the accident. A typology for Industry 4.0 has been modified for mining operators, and it's known as Miner 4.0. This typology includes several key components that help miners perform their jobs more efficiently. One such component is biomechanical support, which increases the miner's strength and endurance, resulting in a superpower. Another component is augmented reality or AI, which allows miners to integrate information from both digital and physical worlds. For example, if there is a problem with a particular piece of equipment, the maintainer can communicate directly with the manufacturer through the special glasses that send and receive the live video. Virtual reality or VR is also used for training, allowing miners for simulate high-risk situation or learn to use new equipment. In addition to wearable sensors, intelligent virtual assistants interface with machines, computers, databases, and other information system. For example, radio frequency identification or RFID tag systems can be combined with the smartphone's app to report, failed equipment quickly. Robots can also use to perform the tasks that are repetitive and strenuous. For example, semi-autonomous machines such as loaders or haul trucks take over driving to and from muck pile, reducing the risk of accidents and improving efficiency. The miner uses the organization's social networking service to interact with the other workers and the Internet of Things. The introduction of the underground Wi-Fi and 5G has made this possible. With the Wi-Fi, for example, operators can use group chats to exchange information. Lastly, the miner uses big data analytics, which will affect how the work is done. New jobs will be created and the old one will be evolved. As a result, tomorrow's miners will be different from today's miners. Digital transformation has its challenges as well. In this slide, we will explore the obstacles the mining companies face as they strive to implement digital technologies. The problems same as legacy systems and infrastructure, data quality and management, skills gap, resistance to change, cybersecurity, and definitely the cost. One of the example of the project in a mining 4.0 has been shown in this slide, and you can see here we have two the important elements of the mining 4.0: innovation and integration. Because previously in mining 3.0 we wanted to use any analytical applications to optimize the processes on the operations separately. But in mining 4.0, we try to integrate all of these operations to make sure we will reach to the overall optimized product. And here you can see we already defined a couple of operations linked together, and now we are making an integrated model to optimize the key effective parameters from drilling to after the crashing or milling. It means that we optimize the parameters to not only improve the efficiency but also increase the energy efficiency, reduce the cost, and etc. during this chain of operation instead of just focusing on one of them. So we know that the digital transformation in mining is a culture, and we need to work in different dimensions. It's not about the technology. Based on this demand, we already established an institute named Soofastaei Institute, focusing on 3 different dimensions, but all of these dimensions are linked together. For example, Soofastaei business is working with a prestigious mining company same as Vale, Rio Tinto, Anglo American, BHP to develop some digital solutions for them and create the product for them. In overall, we have Soofastaei Education to provide the educational program to support that product and train the people that they want to use that applications. And we know that in the market we don't have enough reference books or papers, so we have established Soofastaei Publications to work with the prestigious publishers same as the Springer, McGraw-Hill, CRC Press, etc. to provide the materials that we need for students, for managers, or the people who are working in digital mines. So all of these dimensions have the different platforms, and you can go to the web and search about them, and you can download the materials, and also you have this chance to get familiar with the different products and educational programs. Thank you so much for your time, and this is my contact details. Please feel free to be in contact with me if you need more information or if you are interested in studying in this area or working in the digital mines. Thank you so much and have a great day.